So we are finally getting into the configuration management piece, and I think this is where a lot of light bulbs will go off in terms of understanding our approach. But essentially, we're using the Gluware control engine. We're using a capability we announced at the beginning of this year when we went live with a number of beta customers that had validated it, is config modeling. And so with config modeling, the idea is we call it, jokingly in a way, bring your own CLI. But it's a way to we go into these enterprises and they have the desired state. They say, this is what I want to be. I have network engineers, they know our CLI, they know our designs, they know what should be on the network, but it's just not on the network, right? And so how do you normalize the configuration? And when you start to talk to enterprises about our engine going and making changes on devices, it makes them nervous, and understandably. If you go and are making lots of changes, that's very risky because you're modifying an airplane in flight, right? You're working on the engine while you're flying the plane. So what we're going to show you here is the way to start to break down that problem and start to go feature by feature. And for a customer, a few months ago we deployed. They just started with SNMP v3 update, right? The pharmaceutical example, they started with QoS, but they went, wow, the power of this engine, and they went and did AAA and NTP and Banner and a bunch of other features.
They did 8 total.
8 total features. So the idea is to move away from monolithic golden config files that are on one big flat text file and move towards kind of this object-oriented approach where you're data modeling each feature, and our engine is able to stitch those data models together into as many or as few features that you want to automate. And once the engine is automating them, it is capable of updating them, and updating them in no matter what state the device is in. So if the device has no configuration for that feature, it will write the whole config. If it has a partial, it will complete it. If it has incorrect, it will remove what shouldn't be there and apply it. So a real takeaway here is understanding that while we're leveraging a desired state of CLI, if you will, kind of bring your own design or CLI, the engine, being declarative, is able to handle all those variabilities down at the lower levels. And if you were to script this, you would have to script the intelligence to deal with those variables. Question? Any questions on that? See some minds working back there. So.
I've actually got a question on that because coming back to the modeling, and this is playing off. I can't remember who said it. But I think Nicola was alluding to it. Is there a single source of truth? Like, it seems to me like an IPAM, like something like a lot of us have gotten into using Netbox recently because it's a great tool for infrastructure management. It seems like you would want a single source of truth tied to your modeling so that you understand, okay, this is my loopback addressing plan now, but now I'm going to change it, and now this is the new plan, and all of that would come into an IPAM. Is there integration now for that? And if not, is that planned in the future so that you do have a relationship to that single source of truth?
In the case of IP address management, certainly we can make an API call and pull in an address, right? So there are certain aspects of that. What we do in terms of onboarding features and what you'll see is certain aspects of the features are kind of static CLI. Others are either discovered or pulled elements. So Gluware can manage IP addressing ranges and tables. We can make API calls to pull in from some other source. So when needed or required, we can pull in a variable from an outside source, yeah. But the design really is defined by their own network engineering team. And I think that is actually the big benefit of, instead of Gluware trying to say, this is how you do NTP, right, and have 1 or 2 or 5 models, there are numerous ways to configure each feature for most vendors, right? Okay, loopback source or this, I mean, just all, so to deal with that, the variability and the flexibility of how you can configure each feature, we enable you to bring your own config. So.
Okay. I'll show this to you in a second on how close it is and how native it is for Gluware to just pull these details to this trusted source.
Okay.
Just in a few seconds.
Now, we had a question come in from Twitter where someone was asking if you guys have any thoughts on bringing business process into the policies, or is it still very much a technical tool?
Yeah, I mean, there's a question that comes up often, right? Because if the workflow is automated business process and then manual network change, right, you just kind of broke the chain. So our integration with ServiceNow is an example of a step on integrating with a platform that's doing, let's say, workflow management. So certainly, it's really use case based where API integration is needed. And our CEO, Jeff, likes to use the analogy of even if we had full autonomy set up where we could take input from an external system and execute a change, essentially network operators are not ready for that, right? They don't necessarily want to take information in from a ticket and then have it just dynamically kick off an event. So we're beginning to expose features like this with triggered capabilities, but it's kind of, they're not ready for self-driving cars, but we're giving them park assist and rear view camera and a few features that make it more intelligent, moving towards, kind of smoothing that automation workflow. But basically back to business, it's a ServiceNow or third-party API integration.
So you're largely looking at being a tool to be leveraged by other business process modelers rather than building that into your own product.
I would say yes.
Okay.
Yeah.
Okay, so I have I have my switch here, and I've got this assembly. Remember, the assembly is what's activating features on this particular node, and I have I'm going to activate NTP, and I'm going to activate SNMP on this particular switch, and I'm going to show how this is described here. So let's go and review SNMP. SNMP is fairly trivial. Here you can see that you have a container of your CLI. This one is the trusted CLI that you want to see spread across all the nodes. And you can see this is literally bring your own CLI, right? It's like this is the trusted SNMP design that you want. It's not a recommended reference design that we're pushing. This is literally the reference CLI that you would like to be pushed. And again, we'll show this later. This is declarative, right? So this is what you expect as the end result. So if there are any other SNMP statements within a device, the engine will do that cleanup. If there's any of these lines that are partial or incomplete, the engine will go and fix that, right? So I'll go into the details of groups later. Of course, groups, it's obviously a way to group all these different blocks of CLI that you have. But you'll see later that the group is very important because it's a way to control the boundaries of intervention of Gluware. Let me illustrate this quickly. Class maps, policy maps, is it just for configuring quals? So I don't need to worry about how they're edited and changed. No, well, they also control zone-based firewall. So when you upgrade, change, maintain the quals configurations, you want to make sure that, well, right now this is the quals feature, that you're only maintaining quals and you're not touching the zone-based firewall, feature. I mean, look at ACLs. ACLs, you can have ACLs for routing, ACL for SNMP, ACL for, well, this is quals. I want to only update the ACLs for quals, right? So we'll play with this a little bit later, but this is roughly what a group is. I've got NTP as well here, and NTP here. I don't want to hard code the NTP servers. I want to give the opportunity to operations to be able to manipulate the NTP servers without having to deal with the CLI. So, I'm presenting this to them in the shape of a form, and this is where they can go and add servers, right? I can add this particular server or whatever, NTP server, and this is how the NTP servers are maintained. Before I jump to the CLI that shows how this is used, to note the observation you said of a trusted source, this is what's in the background. This is a JSON structure, right? So this JSON structure is what's containing the NTP servers. And so it doesn't matter where this NTP, this NTP JSON is coming from. Right now, I'm using Control UI to do this. But if you want your IPAM software to push this to us, or you would like Gluware to go and pull this structure, this is also something that we can do, right? So if you look at the CLI resulting of this, if you remember the structure of the JSON, NTP, peers, etc., well, this is just like a crawling of this structure. Which means that with this, the engine will create as many lines of CLI that you've got entries in your table, right? But it means that that CLI is not exposed to the user. So if I want now to just go and deploy this, and by the way, you can see that OS upgrade finished, and I only ask for upgrade only, don't reboot. So I've got an information saying that I need to manually reboot it. I'm going to select this switch, and I'm going to choose a preview. What a preview is, and I'm going to do a connector preview, is that I'm going to show what's going to happen. I'm not doing it. I'm only asking the engine, tell me what you're about to do with the two features that I've put in your assembly. Just show me what you're about to do. And so it takes a little bit of time, just a few more seconds, and then you'll see that I'm going to be able to preview organized per network feature what the engine says that is required, right?
Zoom in on it.
Yes. Let me zoom in. Up. So you can see here, okay, SNMP, it seems that it's going to just apply, this whole SNMP configuration, right? But here's what's interesting. You can see that the first line of NTP, I've got a no statement. Well, it shows the declarative nature of Gluware. It's because I asked for 3 NTP servers, 2222 is not part of it, so the engine this one needs to go away. So you don't need to worry about the current state of the switch configuration-wise, because what the engine is going to do is, okay, I need to put these 3 lines of NTP, and if I see anything else that's not declared in the model, it's going to take it away.
So it's going to normalize the config according to your
right.
standards. So I have a question around that. When you get into something that's not trivial like routing, and let's say you want to go do a change, and you let's say you have 1,000 sites on a global MPLS network, and you're going to go through and make this change that you've validated with your team, and you've tested it, and everything's good to go, and then all of a sudden you realize that out of that 1,000 sites, there are like 10 that had a static route because the carrier edge router, had some policy that was different than the other 990, and you lose those guys in the push because whatever your model was, they didn't fit the model and you didn't realize it. So is there a way, if you have config revert, I'll use Cisco as an example, you could do a config revert. Could that be baked into it to say, hey, I'm going to push these changes, I'm going to blast it out to 1,000 sites, but I want it to go into config revert and give me maybe 30 minutes to an hour to make sure that this is what I want, and then close that out with a confirm so that if you're dealing with sites in Africa or somewhere that's incredibly hard to reach because you have a global enterprise, you're not having to send people out to go deal with that. How does that work when you get into critical operations?
So it's interesting that for Cisco you say you got config revert. Well, unfortunately Cisco is not transaction based, so it's very difficult to revert. Having said that, for specifically Cisco, we developed an agent that gives you this sense of transaction-based like behavior. Mm-hmm. So let's say that one of these static route was the one that allowing you to talk to the box, and you just completely broke routing. There was a question asked earlier: is it what about if I kill my management VLAN? So the agent is able to call home, and as soon as the provisioning is might have finished correctly, right? But you've just lost complete, access to the rest of the network, especially with the Gluware engine. Then the agent will just revert the previous stage just before the provisioning.
So that's a part I guess I didn't pick up on. Where is the agent actually? Is it on the switch?
The agent runs on the switch. This is specific to Cisco right now. We only have done this for Cisco. Okay. Because Cisco has some limitations that others do not have, transactions and this kind of stuff. Okay. And so it's a and the agent does multiple things. This rollback capability, this failsafe, is one of the things that the agent does. It resides on the switch or on the router, and this is a tickle agent that we wrote. It's completely autonomous that runs constantly on the switch.
So in my example, if I have 1,000 sites and I've broken 10 of them, 990 will be committed in the changes that I have, and the 10, the agent's going to roll them back, and then the engineering team's going to go review what broke, what happened.
Yes.
Okay.
Yes.
So can that agent be automatically pushed?
It is automatically pushed. In fact, this agent has also zero touch capabilities. So you can literally take a switch or a Cisco device from factory, there's no need of any bootstrap. You can erase the device, and you just, you can use a USB key as the media to spread that agent, and you just switch it on, and it will automatically, build this initial config, check connectivity, call home, and talk to the engine and say, hey, I'm here, hit me, give me my configuration, and the engine will just.
You say you're doing that with TCL?
Yes.
That's really impressive.
Yeah. Typical libraries on Cisco are at least 15 years old, so there's a way to upgrade and push your own TCL libraries. And
Right. I guess my question with that is I've dabbled in that, and device variance is pretty large. Mm-hmm. Like what you can do with TCL on a switch, 2960 switch versus ISR router is pretty significantly different. Are you guys running into challenges with that, like limiting what you can do, or are you modifying enough that you have?
So we're modifying enough so that any switch, any Cisco device that supports TCL, then we've baselined this across all the devices, so we have the same agent. Yes.
I was not expecting that, TCL.
Yeah.
You don't hear that come out very often.
Yeah, but that's the only language available to you.
Yeah.
Yes. Other platform more recent, you've got other scripting languages, but you can literally take a 37 switch or older that's got TCL router and run it on it. No problem.
So just for as a follow-up for comparison, because I do a lot of work in open networking and white box. So let's take Dell with Dell's OS, because you have Dell on your Dell networking on there. If I have like a Dell 4048 running Dell's operating system, how does that different than Cisco? Because you mentioned the agent is really specifically for Cisco. How would that differ, the rollback or something like that in the same use case, and I'm running a Dell switch?
So some operation systems have transaction support. Viptela's got transaction support. Juniper's got transaction support. They all have, these mechanisms built in. The reason why we did this for Cisco is, well, initially our first love was Cisco, and we spent a lot of time trying to compensate, these vital mechanisms that you require in order to get the most of the Cisco devices. Now, on the vendors that do not have that have these mechanisms, we use them, right? Mm-hmm. If you have a failure on a box that supports transaction, and we make the distinction between revert and rollback, right? A failed provisioning versus a successful provisioning, but you don't like it anymore, then we do support all that, right? So failed provisioning, you made a mistake in the CLI, then the engine will say, oh, well, something wrong happened, and it's just going to roll back, because this is built in within the OS. So this is what the vendor-specific extension that we've got, we can all that knowledge, the semantic, the syntax, and also all these built-in mechanisms that the operating system is capable of. This is what's built in.
I guess the piece I'm missing is, like in Cisco, there's an agent that's calling home and saying, oh, I can't call home anymore. Let's roll back the config. If it's broken, like in a Dell, where I assume there is no agent because you said it's transactional, how does that rollback occur exactly on something like that, or any operating system you support that's transactional? So
if it's transactional, we invoke just the rollback mechanism or the revert mechanism. For platforms that do not have this, then obviously there's an extra step where we connect onto the device, and we just do this process, the similar process, but this cannot be triggered or started from the device on its own. That's the only difference with agent versus no agent.
Okay.
So just to wrap up this demo, because we went a little bit long in this segment, can you navigate to globals?
Yeah.
In one of the packages that we loaded when we initially kicked it off was a simulation of what we call onboarding, where a enterprise says, hey, here's an example config from a few devices, and we port them into the system for them. We essentially deliver the building blocks that they then can fully edit and augment and go, going forward. What we showed you was, taking a device and starting to map in features that Gluware is going to configuration manage, like NTP and SNMP. You can keep adding features, and you're essentially teaching the Gluware engine what it cares about. So those features really become force multiplied, because I can tie one NTP feature to hundreds or thousands of devices and have it consistent. If I need to have a few different copies, like an NTP North America, an NTP South America Central, I can have different copies of those instances and tie those to the assemblies for devices in those regions. So you get really a force multiplier effect by leveraging these building blocks of features and assemblies. But it was said before, there certainly is that kind of normalization or cleanup process that has to occur. And sometimes it's easier to start with certain features and then move towards the more complicated, right? So something like routing is more dangerous to change and more complicated. We certainly probably wouldn't start with that in most enterprise. We're going to start cleaning up globals, making sure I'm compliant for log verification and user management and all these other features, and move in towards the complex.